All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our natural language module. Let's have a look at what we went over tonight. Now, last night, if you recall, we just went over using the recurrent neural networks to actually put our sequences into our network and then having it produce a hidden state that both got fed into the next word, that both got fed into another hidden state, so on and so forth. We call that our encoder that it got fed into. So this would be our word we put into our network. Our network put into an encoder or a hidden state that produces a new word, and so on and so forth, all the way down until we got to the section of decoding, where the encoding ended and the decoding started. And you can see here it was the same process, just on the decoding end. Tonight we're going to look at a different aspect of that, but let's pick up with some light reading. And so this then is how we can use a recurrent neural network to take some input, encode it into some hidden state, and then use that hidden state to decode it into the output we're interested in. To visualize it in a slightly different way, we have some input sequence. This is some sequence of words. That input sequence goes into the encoder, which in this case is a recurrent neural network, generating these hidden states along the way until we generate some final hidden state, at which point we start to decode it, at which point we start the decoding process, again using a recurrent neural network that's going to generate the output sequences as well. So we got the encoder, which is encoding information about the input sequence into the hidden state, and then a decoder, which takes the hidden state and uses it in order to generate the output sequence. So let's take a look at what that looks like. This is just a different look at what we did earlier. So you can see this here. This is just a different version of this here. Let's walk through the steps here. So this first half is going to be our input sequence. This input sequence gets fed into the hidden state, as you can see here, it gets fed into the neural network, gets passed through a hidden state along the way until we get to the final hidden state here. That's when we stop our, what do you call that there? Our encoding. So all of this is the encoding section of it, of the input sequence, or the encoder. The information goes in, gets encoded, it comes here to this final hidden state, and we start the decoding process. That's when we start producing outputs. So you can see here we have the same process, but this time we're decoding instead of encoding. We're producing outputs instead of taking in inputs. So that's the only difference is we just having a different look at the same thing we did last night. So we have our input sequences going into the encoder, passing through the neural network in hidden states, coming to this final hidden state here, and we start the decoding process, and we start producing output sequences until we get to the end state here. That ends the program. So pretty much the same. But there are some problems, and for many, but there are some problems, and for many, this was the state of the art. For many years, this is supposed to be, one I'm tripping over my words. Sorry about that. Okay, but there are some problems, and for many years, this was the state of the art. The recurrent neural network and the variants on this approach, which were some of the best ways we knew in order to perform tasks in neural and natural language processing. But there are some problems that we might want to try and deal with, and have been dealt with over the years, and try to improve upon this kind of model. And one of the and one problem that we might notice happens in the encoder stage, this stage here. We've taken this input sequence, the sequence of words, and encoded it all into the final piece of hidden state. This piece right here. Well, this piece right here. This piece is the final piece of hidden state for the encoder. Okay. And the final piece of hidden state needs to contain all of the information from the input sequence that we need in order to generate the output sequence. And while that's possible, it becomes increasingly difficult as the sequence get larger. For larger and larger input sequences, it's going to become more difficult to store all of the information we need about the input inside that single hidden state or that single hidden state piece of context. That's a lot of information to pack into just a single value. It might be useful for us when generating output to not just refer to that one value, but to all the previous values generated by the encoder. Right in hieroglyphics here. So basically, just to give you a recap of what I just said here, we don't want to try to squeeze all of this information here from the encoder, all of the input words that we have, and all of the hidden state information into this final piece of hidden state here. We want to try to somehow spread it across everything, so we can not put a burden that big of a burden on this hidden state here. No telling because of the context or the words that we have, or a lot of words, and it's a big file, a bunch of words we're trying to feed into that final piece. Maybe we run into problems, or maybe to have an issue running that large of a context. So yeah, we try to spread it across the entire encoder field instead of just trying to squeeze everything into this final piece here before we start the decoding process. Okay, and that might be useful, but how can we do that? We have a lot of different values we need to combine somehow. So we can imagine adding them together, taking the average of them, for example, but doing that would assume that all of these pieces of hidden state are equally important. But that's not necessarily true either. Some of those pieces of hidden state are going to be more important than others depending on what word they most closely correspond to. The first hidden state most closely corresponds to the first hidden word or the first word of the input sequence, and the second hidden state most closely corresponds to the second word of the input sequence, for example. Some of those are going to be more important than others. So let me take it back to the top and show you again. So this hidden state here is going to more closely correspond to this first input word here, and the second hidden state is going to mostly correspond to this second input here. The reason why this hidden state isn't closely corresponding to this one and this one is you can see the flow is going from left to right, so it's going to more closely correspond to the one it came from the information it came from. So that's why it'll be more closely corresponding to the first input and not the first and second. But that's all the reading I'm gonna do for tonight. Like I said, we basically did the same things over and over. It's the same thing as the one we saw up top here. It's just in a different fashion, and we broke it down a little bit more. But of course, we will pick it up tomorrow, and of course, I will keep you posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.